Good afternoon. I know I'm competing with lunch. When I walked through the hall earlier on, there was still quite a queue for the buffet. Is that still the case? Might be worth just leaving it a minute then. You can finish your tuna wrap. And here we go, if you were late joiners. One of the problems with speaking over lunch at an event like this is that you never get to go to the buffet yourself. You're standing here feeling hungry and everyone's eating in front of you. So if you like the presentation, feel free to share some chips with me, something at the end. How's the food, by the way? So? It's conference food, right? So, yeah, that's what you expect. It's free. Okay. All right, I think we're ready to make a start. So I appreciate you've been given what airlines back in the 90s used to call a choice. And for the next 15 minutes, you've chosen to fly Black Duck by Synopsys, an application security in the age of open source. And Black Duck by Synopsys may sound a bit like a British village pub that's been run by a hair salon. But we are, in fact, a open source security software company. You have to pay the bills somehow, and that's how we pay the bills at Black Duck. But we're also the first and foremost code auditor. So we have a code audit business, and that group within our organization is engaged mostly around merger and acquisition activity. So if you've ever been part of a company that has been acquired, you may at some point have been Black Ducked. Our auditors may have been in to do a code review within your organization before now. We've been doing this now for around 15, 16 years. And the fundamental impulse that drives companies to have code audited by Black Duck is normally try and work out what the value of an acquisition target is. So if you're trying to buy another company, you want to figure out what it's worth. So what's the brand worth? What's the real estate worth? But increasingly now, they want to find out what the software is worth. What's the value of the digital assets? And to value a digital asset, same as anything else, you want to understand what are the liabilities, what is the quality of the code. So you bring Black Duck in, we review the code base, and we report back to the acquiring company on the nature of the code that we find. And why is this important? Because the nature of software companies is changing. Everyone, to a degree, nowadays is a software company. And we would argue that if you're not getting your software right, you may not have a product. In fact, in a couple of slides' time, we'll see that if you're not getting your software right, you may not even have a company. So these things are important, and it's what we spend a large amount of our time doing. But what it gives us is this unique perspective into the code bases of the world's largest organizations. We anonymize that data. We have a research institute based out of Northern Ireland we call it COSRI, the Center of Open Source Research and Intelligence. And they pull together the information that we gather from reviewing enterprise code bases, and we issue it as published research once a year in something called the OSRA report, the Open Source Security and Risk Assessment, Risk Analysis report. If you're not a subscriber, then feel free to drop by Stand S5, talk to the team there, and they'll set you up with subscriptions so you get that report once a year. So the information we're going to share with you in the remaining 10-12 minutes of the presentation, most of it is primary source, so it's from the OSRA reports, come from our Center of Open Source Research and Intelligence. You may not have seen it before, so hopefully it'll be insightful. But it's primary source data unless otherwise attributed. Starting, for example, with this piece of analysis from SAP. So this isn't going to blow anybody's hair back. I think we're all familiar with this perennial truth in the technology industry, that investment just always seems to lag behind reality. The statement being made here in this piece of analysis is that the investment being made in securing the enterprise is kind of over-rotated in recent years towards perimeter security and network security, whereas the actual attack vectors and the vulnerabilities tend to be more on the application layer. So a kind of over-investment in infrastructure and an under-investment in a code-level security and vulnerability management. But personally, based upon what we're seeing, this is more an indication of where we've been rather than where we are today or where we're going. I think this is something that a lot of organizations are kind of waking up to. And we're seeing a serious shift in behavior and shift in investment to try and do a better job, or at least match the effort being put into infrastructure level security in the application layer. But if you want to go about securing something, you start with understanding the nature of the thing you're trying to secure. And this is where we have seen one of the biggest changes in the 15, 16 years that we've been operating. So when we were reviewing code and applications that were written in the late 90s going into the early 2000s, we found that 90% of it was just source code. The presence of open source was fairly marginal, sometimes as little as 10% or below. In some industries, in fact, none at all. That's in stark contrast to what we tend to find today. It's not unusual for our auditors to go in and conduct a comprehensive code review and find that up to 90% of some applications are made out of public domain software. So the reason this is happening is that smart developers just like working that way. Community-derived software is a fast way of getting good quality software into production. Everyone knows that. It's not a bad thing. We're great advocates of it at Black Duck. But it means that the nature of the application itself is beginning to change. So if it surprises you that up to 80 to 90% of applications are made up of open source components, you're not alone, because it tends to surprise the organizations that we're auditing. So here is some of the statistics that I've pulled for this presentation out of our OSRA report. And starting down here, we are typically finding twice as much open source than we are told to expect. So usually there'll be some sort of statement, some sort of process that the organization has run where they're able to keep a record of the open source components that they think are in the application. But normally they're wrong by about a half. So on average, we are told to expect around 50 open source components, and we find over 100. So the question to ask is, if there's that much open source that's sitting in a code base but unexpected or undetected, then what lies within that open source? So how much risk is sitting below the waterline that apparently isn't visible to anybody? And we're finding stuff there that's actually quite alarming. So for example, 60% of the applications that we review out in the wild contain known open source vulnerabilities, 67% of them. And 40% of those vulnerabilities are rated as critical or severe. So these are not insubstantial vulnerabilities. These are pretty hairy. 22.5 is the number of open source components that we find with vulnerabilities in each application. So 22 of them have vulnerabilities. 1,894, it's 5.1 years is the average age of the vulnerabilities that we are finding. Now, that doesn't mean that they've been sitting there undetected for 5 years or longer. The sad truth is, a lot of the time, we're finding 5-year-old vulnerabilities in applications that had only been written the year before. So what that tells us is that they're being written from the beginning with potentially exploitable software, because some degree of, not diligence, because it's not the responsibility of the developer, but some lack of process has meant that a vulnerable open source component has been allowed into a distributed application. And 10% of the applications that we review, we're still finding Heartbleed in. So Heartbleed hit the streets back in, whenever that was, 2014. So 4 years have passed, and despite the fact that everyone's had their hair on fire for that period of time, 1 in 10 applications that we are reviewing, we're still finding that vulnerability because it's hidden in a previously undetected open source component. So why is this happening? This is happening because the nature of the application has evolved in recent years, but the methods used by which to manage security has not. So whereas you might have been running something like static analysis to see if there were any vulnerabilities being created in the code that the developer's writing, or if you're using pen testing to do a similar thing, but later in the software development lifecycle, all of that was looking at vulnerabilities that have been created by coding errors. But they're not focused at finding vulnerabilities that sit within open source components. So as the amount of open source has switched from being marginal to being the majority, if the security processes and practices around looking for vulnerabilities in that code base have not changed, then the risk increases significantly. Do you follow me? So what we tend to find is that the difficulty is finding the open source in the first place. That's the harder thing to do, is detecting open source, because the nature of open source is that it's complex. A single component could have a tree of subcomponents that sit beneath the surface. A build script could run a command that brings in transitive code, and sometimes this can be very generic. It can say things like, just go and get the latest version of Apache struts and bring it in, whatever the latest version may be. So if you don't have a system that has the intelligence to understand what a build script requires when it runs, then transitive code can come into an application at build time that was never in your repository, that was never in the spreadsheet that you're using for recording the use of open source or whatever your process may be. And the nature of open source means that it can be heavily modified. So it can be obfuscated, either accidentally or in some cases maliciously, so that open source components with all of its identifiers and signatures stripped out can still be sitting in a code base. And then if this is something that is attempted to be managed manually, what we find is organizations run immediately into problems of scale. So just last year alone, there were 3,000 new CVEs, vulnerabilities, that were listed on the NVD and elsewhere, some of the private sources such as Black Duck's own knowledge base. So 3,000 last year alone. So that's the rate of 8 new vulnerabilities every day. So if 8 new vulnerabilities are getting listed every day, and you have responsibility for finding vulnerabilities in potentially many hundreds of applications, you realize pretty quickly that this isn't a problem that human beings can fix. There is a need for a process, there's a need for automation. And this, we think, is the root of the problem. Is the nature of the application has changed, the risks of exposure to vulnerabilities has increased with the use of open source, but the challenge of managing the use of open source has gone beyond the point where it can be properly done through manual process alone. That's our analysis. But you don't have to have Black Duck's line of sight in the industry to know that people are struggling with this. So one of the most recent and highest profile cases was last year with Equifax. So Richard Smith, who was the former CEO of Equifax, when he had his hearing in front of the House of Energy and Commerce in October last year, he said this. He said, we received CERT's advisory on the vulnerability in Apache struts, and we scanned their applications, but we failed to find it. But it turns out that what was happening was that they were scanning the source code that their developers had written in their applications, but they did not have a process for doing something similar with the open source that was present, and that's where this vulnerability that was ultimately exploited lay. And the difficulty there for people like Richard Smith is not actually the presence of a vulnerability in his code base, because that's normal. You will have them today, you will have them tomorrow. It is just part of the software industry. The problem was having a vulnerability but not having a response plan. Not having an adequate response plan is not normal in the eyes of the regulator, in the eyes of the general public. So if there is a new high-profile vulnerability that hits the streets, expectation is that between them, the security team and the development community in any organization should be able to quickly answer 3 questions. The first is, does this impact us at all? Should we be worried? Do we even have this thing? Second thing is, if we do have it, where is it? How quickly can we heat map our code base and find exactly where it is that we have the risk? And the third thing is that once we've found it, what is required of us? How do we patch? How do we remediate? How do we get us and the organization to safe ground quickly? So if a process does not exist to answer those 3 questions, then there is inherent risk in the organization. And that's the type of thing that our auditors would mark down when we review a code base and the process that's been put in place to manage it. So the question is, who's responsible for all of this? Well, in the world of commercial software, that's the vendor. The vendor will give you a patch, the vendor will give you a fix, they will automate or push out the path of remediation. But if you use open source and consume the component through the community, then the responsibility sits with the user. It's your job to have a process, it's your job to find that the vulnerability is there, and it's your job to remediate. And what we find is that's normally being managed through a fairly lightweight process. It's usually some sort of manual tabulation, some spreadsheet-based inventory. There are some free tools out there that do a very simple job of kind of parsing a manifest off to the MVD and kind of cross-referencing them, but it's very superficial. And sometimes it's kind of wrapped up in some kind of knee-jerk tracking of major vulnerabilities, and sometimes some sort of pen testing at the back end. A lot of it, though, doesn't really go deep enough. So the final point to leave you with, because I'm kind of running out of time already, is what does good look like? So if that's what bad looks like, what does good look like in our eyes? What would we give a green light across the panel for if we were to go in and see a really well managed process? And it kind of looks something like this. But before I take you through it, just a disclaimer. We're not assuming that this is important to everybody, right? So not everybody cares about this, and not everybody cares about it to a point where it's a priority today. What I can tell you is that if you do care about it, you probably care about it a lot. So if it is important to you, then these are the kind of 5 things that we would prescribe. And the first is have some way of accurately creating a bill of materials for the open source you use in every application. And if you're going to go and find it, make sure you find it all, because having a process that only finds some of it, it's like having a smoke alarm that only works kind of half the time. It's not really going to do the job. Second thing is have a means by which to map those open source components to known vulnerabilities. So have some cross-referencing mechanism where you can match the components that you have with vulnerabilities in the MVD and elsewhere. Secondly is have a process for identifying adjacent risk. So we see this quite often where a component is swapped out because it has a vulnerability and is replaced with one that does not have a vulnerability, but the old component was under a permissive license and the new component is under a GPL license. And whilst the security team are happy, now the legal and general counsel's up a tree because you have a completely different type of risk. And by the way, we find 85% of the applications that we audit have some kind of license compliance issue as well. So risk doesn't just sit in security, it's an operational risk, it's a legal risk. So you need to have a means of also appraising parallel risk, so you're not just kicking the can down the road and create a different kind of problem. Have a means of putting a policy in place, create a policy for the use of open source, and automate it if you can, so that we can just put some crash barriers on the motorway that allows development effort to move faster. That's really what we'd recommend. Not putting a process in that slows down the pace of development. Quite the opposite. As we see that open source can speed up time to value delivery of software. But it would need a means of doing that whilst making sure that there isn't a risk being introduced to the code base. And then finally, have that response plan. If there is a new high-profile vulnerability or a vulnerability of any type that should affect you, make sure you have a system that alerts you the moment that CVE is posted, so that you know what the remediation path is and you have the answers to those 3 important questions that should be in your response plan. Automate. This isn't a problem that can be fixed by human beings. It just won't scale. And find a way of integrating it within your existing tools and processes. So don't try and do something separate. Don't have a kind of workflow based. We've seen this a number of times. Again, it's counterintuitive and counterproductive. It's better if these things are integrated and automated. That is all I have time for. Some questions here behind me if you want to kind of go and have a conversation internally in your organization about some of the challenges that I've highlighted. I hope this has been interesting to you. It was only supposed to be a quickie session, so I wasn't given time to go into this in much detail. But myself and my colleagues downstairs, we're in stand S5. If you want to drop by and have a more in-depth conversation, happy to do that. Maybe even pick up a little black rubber duck. So useful? So I had to rush through it, but I'm happy to take questions down on the stand. But thank you.